All right, guys, talk about this lab real quickly. I'm just going to blast through it. If you have any specific questions, reach out to me. But I graded them, and you guys did a great job. But a couple points that you might have been confused upon, or what I'd like to talk about. Starting with this first one, the three parts of a working circuit. You need three things. You need the voltage source, which is what's ever going to be responsible for pushing the electrons around. So that's the battery, might push the electrons around. The outlet in the wall that gets power from the power station might push the electrons around. But you need a voltage source. That's what that's called, voltage source. The second thing you need is a conductive loop of wire or of some conductive material. It's going to be a closed loop. The third thing you need is what we haven't really talked about, but it's, I don't know, the whole reason we do this. It's whatever you're going to power. It's whatever you're going to use with this, whatever the appliance is. That could be an electric toothbrush, possibly a vacuum cleaner, or even a light bulb. So we'll use light bulbs a lot because they're so simple and they're cool because you can see the power or the energy go right through them. All right, you guys did great with that part. So let's move on to where the next bit we got to this battery voltage thing. I just wanted to talk about that a little bit. So I'm going to just draw it a little bit and we'll talk about it. You remember, I wish I could show you the simulation, but the software won't let me do that. So we'll do this instead. Okay, you may remember that there was like a battery here, and there are little dudes inside there, little guys that were floating around, and what they were doing was pushing electrons to one side or the other. And what we found is if you had a side where all of the electrons are all kind of bunched up there, and very few on the other side, then what we say is there's much more potential to push the electrons around over here because they repel from each other. So when they're all crammed together, that's a lot of potential. Over here, there's not as many electrons, so there's not as much potential to get pushed. So the big story is if there is a difference in potential, which means it's harder, they're pushing harder off one another on one side than they are on the other. If that exists, that is what we call a voltage or a voltage drop. We'll get into that later. So what that really means is that if you can somehow connect some conductive path from this side to this side, all these electrons now have somewhere else to go when they push off each other. They'll fly around, they'll come to this side, and what you end up there with is a current, which flows in that direction. The opposite direction, actually, because current is the flow of positive, and the electrons is the flow of negative. So that's the deal with that. All right. The next part of the lab used the simulation where you could play with the resistance. You can make the wire really fat, you can make the wire really short, and then you can find out what was going on with what that did to its resistance. You did a great job with that. You may have some problems or some issues. Maybe people were a little bit confused by what that resistivity thing means. That thing there shows up again. It's called resistivity. And what that really means is it's just the nature of the material. And it has it's sort of a measure of how difficult it is to push current through there. And sometimes it helps to think about what's really happening when you're pushing current through a wire. You know, there are atoms in here of the wire and electrons that are trying to get through the wire. And these guys got to get in, but they can only do that by getting through these different atoms. So they're going to have to bounce off this guy, then bounce off that guy, and then bounce off that guy, and then bounce off that guy, and then bounce to wherever they're going. You have electrons in there all the time. Now, if something has low resistivity, that means they can just kind of just fly right through there, no problems. So low means easy to get through. I'm sorry, this is so sloppy. It's not easy to write with this pen. And if it's easy to get through, these atoms aren't bouncing around very much, so you don't lose a lot of heat. Remember, bouncing particles is what heat all is. That's what it's all about. However, if you have something on the opposite end of this, if something has a high resistivity, then that means it's hard to get through. So what you have there, think about like a crowded party. If you're trying to get through here, you got to really push these guys out of the way. Hey man, excuse me. Hey, pardon me, excuse me. Now you got people jiggling around like crazy. And then once you have that, you have a lot of heat that then leaves the system. So what that really means is that if something has a low resistivity, it's easy for the electrons to get through, and the atoms in the material don't bounce around very much. If something has high resistivity, that means that it's hard for the electrons to get through, which means it really has to bounce the atoms of the material around a lot. And because the atoms bounce, it gives off heat. Okay, I appreciate you guys taking this stuff seriously. You guys are doing great work. Everybody's scanning things and sending it in. It's really cool. Way to get together and make it happen, guys. E-Learning 2020. Woo!